Okay, so the rules of exponents have to do with how to simplify exponential expressions. And so what do you do with exponents when you're multiplying and dividing terms with exponents? We're going to focus on 6 rules, and my goal is not for you to memorize the rules, but that you can make sense of them so you don't need to memorize them. So they just kind of logically flow. It's supposed to be like waves. Okay. So the first rule we're going to talk about is called the product rule. And it's called the product rule because it's discussing what happens when you multiply 2 numbers that are exponentials. So they have exponents and they have the same base. And so this particular rule, if you look at it, x cubed is x times x times x. That is x cubed. X to the 5th is x, 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 x. There is x to the 5th power. And so how can I write this then as one exponential expression? X to the 8th, good. So what did we in fact do to those exponents? Yeah, we added them. So when you were multiplying, you add the exponents. And it makes sense when you write it out, because when we write it out, we see x cubed is 3x's being multiplied, x to the 5th is 5x's being multiplied. So in total, you have 8 of them. So what you can do shorthand, instead of writing it all out, is you can just add up the exponents. So this is the product rule, which says when you're multiplying 2 numbers with the same base, you add the exponents. Now I'd like you to notice that the x stays x. It doesn't become 2x, it doesn't become x squared, it's just still an x. And again, that makes sense when you multiply it out, but when you put a number in for the x, it can get a little confusing. So make sure all you're doing is you're adding the exponents, the x stays the same, so the base stays the same. Okay, and that's the product rule. All right, so Amelia, how about the first one? 2 to the 3rd times 2 squared.
So you have to change this before.
So it's x, x, and then still x. So instead of being 4 to the 5th,
Oh.
2 to the 5th, yeah. And so that's where it's confusing because you think, oh, I'm going to multiply. But the act of multiplying is accomplished by adding those exponents. So it's still 2 to the 5th power because 2 to the 3rd is 2 times 2 times 2. And then 2 squared is 2 times 2. So that's why it's still a 2 to the 5th power. All right. Brendan M., how about this bottom?
X to the 6th. Here's 7.
7, good. So when a base doesn't have an exponent, it might help you to write that as to the 1st power, just so you don't forget about it, and then you remember to add all of them. So Brendan, you said it was x to the what?
7.
X to the 7th power. Good job. Questions on that? Okay, so that's the product rule, called the product rule because you're multiplying 2 quantities together. All right, now for these examples, what you're going to see are some coefficients and some exponential factors. So 2 and 4 are coefficients. So with the 2 and the 4, you're just going to multiply these together as you would always. So the 2 times the 4 is 8. So you multiply those together. And DJ, what would you get if you multiply x cubed times x to the 8th?
You get 11, or x to the 11th power.
Good. So that's going to be 8x to the 11th. And Maggie, this next one's a big one. Think you can handle it? Okay. Okay, so let's check it out. For the x powers, she had a 2 and a 5. So that 2 and a 5 gave her that 7. And then for the y power, she had a 3 and a 9. And the 3 and the 9 gave her 12. Okay, and then she multiplied the coefficients together. Right, any questions on that? Okay, so your brain does weird stuff with this because you're multiplying the -4 and the -3, but then you're adding the exponents. So that's something you have to keep straight because we just added the 2 and the 5 to get the 7. And the reasoning for that is x squared is x times x. X to the 5th is x times x times x. And really there are 7 x's when you write them all out. There's not going to be 10 of them. You wouldn't multiply those two numbers together. Rule number 2 we're going to talk about is the 0 exponent. Ashley, can you give me a couple of these, like what 2 to the 5th, 2 to the 4th would be? Do you know what 2 to the 5th is? So that would be
Oh,
2.
wait, sorry.
That's okay. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 2 to the 5th.
So if we, I can't do this one.
Okay, do you want to pick some others?
Yeah, so 2 to 0 would be 0, 2 to the 5th would be 2, 2 to the 7 would be 4. 2 to the 4 would be 6.
Let's remember it's 2 times 2 times 2.
Oh, so I think it's
8. Then
and then 2 to the 4th would be 6. And then 2 to the 5th would be 6. So it'd be 20.
16 plus 16.
And 32.
32. Beautiful. Nice job. Now, I want to show you, I'm just going to move this one over to the 8th and 16. And I left this one off for a second just because I wanted to demonstrate something here. 2 to the 5th is 32. One of the ways I remember that without having to do the math is 32 if you, oh, sorry. Right here. 32, if you add those digits, you get 5. So that's how I remember 2 to the 5th is 32 because 3 plus 2 is 5. 2 to the 4th is the same as 4 squared. You flip those, so that's 16. That's just a fun little fact. And then there are the rest of them. If I wanted to go down this kind of these rows like a pattern, what would I do if I went down the rows? What's the pattern to get you to go from 32 to 16? TJ?
Divide by 2.
Divide by 2. Good. So Twinkle, if I continue the pattern, what would 2 to the 0 be? So if you take a look up here at what the pattern's happening, every time we go down, we divide by 2. What would the last one be? Yeah, it's 1. So 2 to the 0 power is 1. And it doesn't really make sense after we stop talking about, like, 2 to the 1st is 2 times itself once. 2 squared is 2 times itself twice. 2 cubed is 2 times itself 3 times. 2 to the 0, talking about it that way no longer makes sense. 2 times itself 0 times. That doesn't make any sense. But what we can do is look at it this way as a pattern. Every time here to get down this pattern, we divide it by 2. And then when we get to 2 to the 0, we get 1. So 2 to the 0 power is 1. is defined as 1. And so that gets us to our zero exponent property, which states any number to the 0 power is 1. And the reasoning for that is that pattern, okay? If we take like powers of 3, 3 cubed is 27. 3 squared is 9. 3 to the 1 is 3. We can see the pattern here forming. You divide by 3 to go down the pattern, and then if we divide by 3 again, we get 3 to the 0 is 1. So you can kind of show that any number to the 0 power is 1. So that is called the zero exponent property. So, Isabel, what's 7 to the 0? 1. Brendan, what's 3xy to the 0 power? 1. Talisa, what is x to the 0 times x to the 9? So look at what's being asked. Well, part of it, x to the 9. Good job. Okay. So you could look at this in a number of ways. We could look at it using the product property. The product property says if you have two numbers with the same base, you add the exponents. So adding the exponents, 0 plus 9 is 9. Another way to look at this is x to the 0 is 1. 1 times x to the 9 is just x to the 9. So you can look at it either way. Okay, this is a tricky question. -2. Isaac, what do you think?
-2 to what power?
0.
Oh. 1.
Okay, I'm going to write it another way, which actually yields a different answer. One of these, the answer is 1. Isaac, which one do you think it is? -2 to the 0 or quantity -2 to the 0? Which one has an answer of 1? Well, this one does. Because this one says take -2 to the 0 power. This one, because of the orders of operation, says take -2 to the 0 power and then make it negative. It's -1.
You know how you could write like 2 to the 5th and you can like write out the whole problem? How would you do that for the 0? Or you just can't do that?
You can't. Unfortunately, that's where that particular construct goes away, which is why I like to, when I'm trying to figure it out, I just look at this pattern to figure it out instead of, because you can't write something 0 times. So -2 to the 0 power using the orders of operation states take the number to the exponent first. Because when you look at orders of operation, it's parentheses first, which there are none, and then exponents. So you do 2 to the 0 power, which is 1. So that's why I kind of circled, well, I kind of circled this. I do 2 to the 0 power right here. And then later it says multiply. Making something negative is like multiplying it. So you do 2 to the 0 and then you make it negative. So -2 to the 0 power is -1. It's not positive 1. But this is 1 because this says take -2 to the 0 power. This says take 2 to the 0 power and then make it negative. So it's all about the order in which you're asked to do things. Questions on that? Okay. Next we have a quotient rule. You guys know that quotient means to divide. And so to demonstrate this one, I'm going to do, I'm going to write it out. It's called expanding. And so if I expand, I can write x to the 7th as 7 x's being multiplied over 3x is being multiplied. Now, how many of these x's cancel out top to bottom? 3. So I can cancel out 1, 2, 3 of them top to bottom. And now, how many am I left with on the top?
4.
So I could write the answer as x to the, x to the 4th. And Denise, is there a quicker way that I could have done this besides writing it all out? You could have divided. So is 7 divided by 3?
I mean, it's not subtract.
Subtract, yeah. See, that's where you are dividing, but to accomplish dividing in exponent land, you subtract. So to divide, you subtract the exponents. So we'll subtract the exponents, and then you don't have to write it out. You don't have to expand it. But you can see if you do expand it, how 3 of those cancel out, and you're left with x to the 4th on top.
So do you want us to write it not because we can just write it?
Well, I prefer that you get to a spot where you can skip this middle part because it's not very efficient. But if you're ever not sure, this is how you get the right answer if you write it all out. So if you're like on a test and you're like, oh, I think I might have mixed up the rule, I always say, when in doubt, write it out. Tagline for this chapter. Because then it's just like apparent what's going on. You're like, okay, I understand what's happening. But I wouldn't in general, because that's just kind of what he's doing, right? And running x and stuff all the time. And sometimes it'll be like x to the 24. And no one wants to. So this is the quotient rule, that if you're dividing two numbers with the same base, they both have a base of x, you subtract the exponents. So it's x to the a minus b power.
So what if it was like x to the 3rd and the y to the 2nd? Like over.
So x to the 3rd over y to the 2nd, do they have the same base?
No.
No, so that means this is simplified. Okay. If they don't have the same base, that's just how it is. But if they do have the same base, you can subtract. Next question,
What if there was a greater number on the bottom?
okay. So if there's a greater number on the bottom, like x squared over x to the 5th. So Lisa, what would you get when you subtracted those? X to the negative 3 power. Yeah, and we are going to talk, I believe it is first thing tomorrow, about what negative exponents mean. Okay. X to the negative 3rd power is actually the same as 1 over x cubed. And the reasoning for that is if we expanded x squared is xx, x to the 5th is 5 of them. So if we expand x squared over x to the 5th, you can see that 2 pairs of these would cancel out. And so on the top, you're just left with 1, because if you divide two numbers that are exactly the same, you get 1. And then on the bottom, do you guys see how there'd be x cubed on the bottom? So it's 1 over x cubed, which is equivalent to x to the negative 3. So that we're going to talk about when we talk about the negative exponent rule, the fact that these are the same. All right. But when you're dividing, you can subtract the exponents, and a negative exponent is a real concept. And what it means is 1 over x to the 3rd. Good thinking, you guys. All right. So let's take a look. All right. So Denise, x to the 8th over x squared.
X.
Yes, good. Get rid of that line. X to the 6. Now, it's tricky because you're like, oh, I'm dividing. I'm going to divide the exponents. Don't do that. The rule is subtract the exponents. Because in reality, you're canceling 2 x's with 8 x's on top. So you leave with 6 exponents. You are subtracting. That is the reality. Ava. For this next one, you have to reduce this fraction. Okay. So Ava, what is 2 over negative 4 reduced to? Negative 1/2. And I think it looks better to put the negative on the outside. And then how many x's will we have? So this can reduce as any fraction. And when you're dividing a positive by a negative, you can put that negative on the top, on the bottom, or on the outside. All of those just mean the fraction is negative. So I just don't like it on the bottom, it looks weird. And then Ava subtracted these and got x to the 6. Okay, Amelia, how about that last one?
That was negative 2.
Okay, any y's? No, that's good. So the y to the 6 actually just cancels out. And when you think about this, this would be, if you subtracted the exponents, y to the 0 power. But what is y to the 0 power equal to? 1. Okay? So 1 doesn't change the quantity at all. So it's just negative 2x cubed. Questions on that? And you'll hear me sometimes x squared is x to the 2nd, x cubed is x to the 3rd. Because a square has 2 dimensions and a cube has 3 dimensions. That's where those terms come from. So there's our quotient rule. Quotient means dividing. This is the power of a power rule. Power of power is when you take a exponential quantity to a power. And I'm going to write out what's happening here. This is x squared times itself 4 times. So that's what it means to take something to the 4th power. It means you multiply it by itself 4 times over. So x squared times x squared times x squared times x squared. And for an m, what do we get when we do that?
X to the 10.
Went a little far.
Oh, sorry, 8.
X to the 8th. Good. So that is going to be x to the 8th power. Now, Davian, can you see a quicker way to do this besides writing it all out? Yeah. You can multiply the exponents. So if you have power of a power, you multiply the exponents together. This is the first time we've multiplied exponents. Before we were adding or subtracting them. So the only time, excuse me, you multiply exponents is if, and you kind of look, you see how the 2 and the 4 are so close together? They're very next to one another. That in your brain should tell you to multiply. The difference between that and that, people get confused. This is not power of a power. This is the product rule. What do we do here? We add them. So this is x to the 6th. So don't confuse the two. This is power of a power, because you have a power right next to a power, and you multiply, because we really do have 4 of those x squareds. Here you have x squared times x to the 4th. This is not power of a power. So that is the product rule. Those we add. Power of a power, you multiply your exponents. That's the rule in general. All right, so DJ, how about this first one?
That would be 2 to the 24th power.
2 to to the 24th power. Good job. And clearly we don't want to calculate that. It would be scientific notation. It would be all these digits. 2 to the 24th is the best way to represent that. Maggie, how about x cubed quantity to the 6th power?
X to the 18.
Good. Now actually this one has a couple of steps. So you are still going to use orders of operation here.
So it'd be X to 12. And then, so it'd be 5x squared X to 12, and it'd be 5x to the 4th.
Okay, how do you guys feel about that? So she had to use actually 2 different rules there. She had to use the power of a power rule. I'm trying to get that to So she used the power of a power rule. Power rule to find x to the 12. And then she had to use the product rule here to add the exponents to get x to the 14. Okay? And in a lot of these problems, you'll have to use like a whole bunch of different properties together. So thinking of how they will work together using orders of operation is important. Okay, so Twinkle, what would you do first with this one? Okay, so what do we get when we do that part of it? X to the 12, so we get negative 6x to the 12 over 3x squared. Okay, and then what? So here you have either being divided. Beautiful. And what is the number that goes out front? Beautiful. Okay. Good. So this one, Twinkle utilized the power of a power rule here to multiply the 3 and the 4 to get x to the 12. Then she had to use the quotient rule to subtract the exponents and get x to the 10th. And she had to divide the coefficients just like regular numbers there to get that -2 coefficient. All right, questions on that one? Okay, next we have what's called the power of a product rule. And you don't need to know the names of the rules. I'm giving you them because why not? But power of a product means you're taking a power of more than one quantity being multiplied. So here you're taking the power of 5 times x squared. So for these, this is, if you wanted to write it out, 5x squared times 5x squared times 5x squared. That's what it means to cube something. You multiply it times itself 3 times over. So Isabel, how many 5s do we have? It would be 5 to the what? Well, what's the power of the 5?
Oh, 5.
5 to the 3rd, x to the 6th power. Good. So 5 to the 3rd, x to the 6th power, because she had 3 5s. That's what made it 5 cubed, or 5 to the 3rd power. And then x squared times x squared times x squared. You add the exponents, you get x to the 6th. So power of a product rule means you have to give that power to all of the different factors in that parentheses. So it's 5 cubed and x squared cubed. Right? Now if you want, since 5 cubed is a relatively small number, you could call that 125x to the 6th. If you want, it's up to you. But again, if it's like 2 to the 24th, do not multiply that out by calculator or by hand. All right, so the power of a product rule states if you have 2 or more factors to a power, you have to give the power to both of the factors. All right, so Brendan. Okay.
So it would be negative 2 to the first power and x to the third power.
Okay. Now I want you to notice that I put negative 2 in parentheses. That's because you do in fact cube all of negative 2, not just the 2. In this case, it doesn't really matter because when you cube a negative, it stays negative. But if you took it to an even power, it would matter. Brendan, what is negative 2 cubed?
8.
Positive or negative?
Negative.
Negative. So that one I'd probably simplify. So negative 2 cubed would be negative 2, just to write this out, it's negative 2 times negative 2 times negative 2. So if you cube a negative number, the negative is preserved. The reasoning for that is that when you multiply these together, you get a positive 4. And then the positive 4 is multiplied by the negative 2, making it negative again. So whenever you take a negative number to an odd power, it's kind of like being on an outing where there's a whole bunch of couples and then there's that one single person, right? So the one single person is like the negative. It makes the whole, it makes it sound like it's a negative thing. It's okay to be single or with a boyfriend, or it doesn't matter to me in terms of your life choices. But you have a number of pairs, and then you're going to have one negative, which makes it negative. And yeah, that sounded very judgy. Not judging at all, but that last negative makes it negative. So we have negative 8x cubed. All right, Isaac, how about negative 3? I just skipped you, Talisa. I did not need to do that. Talisa, how about negative 3x squared quantity to the 4th?
Do you have to put the negative 3 in parentheses?
You do.
For that times. Then put x 6.
The power of a power. 8. Yep. Sorry, the iPad was like that. There we go. So, if you take a negative to the 4th power, does it stay negative? No, because you have a negative times a negative, which is a positive, and another negative times a negative, which is a positive, so that's a positive. All right, so what is negative 3 to the 4th power? The easiest way to do this one is to multiply 2 of the negative 3's. Yep. It's 9 times 9. That's going to be the fastest way, because then you don't have to get to 27. You just do 9 times 9. So it's 81x to the p. There we go. So that's a pretty low number. You can just calculate that. Okay, Isaac, you ready? You look super ready. All right, tell me what to do.
We start by splitting the 3 into the parentheses.
Okay.
So it would be negative 5 to negative 5 cubed and x to the 4th power and then negative 3.
Okay. Anything else I can do to simplify this?
Get x 5, 2. So that'd be negative 116.
So according to the orders of operation, what is being done between all these factors? The negative 5 cubed, the x to the 12th, the y to the third, and the 2 to the third. What's being done between those? They're being multiplied. Good. Times just fine. Right. So what is negative 5 cubed? Yeah, so that's negative 125. What is 2 cubed? I think you're doing 3 squared. 8. Okay. So you would really need to calculate those before you're able to multiply them. Or I guess that might be the easiest way. So what do we get when we multiply those together? 125 times 8. 1,000. Good. Negative 1,000. X to the 12 y cubed. And you do have your calculator, so you can use those. I just thought of it as money, like $1.25 times 8. $10. Questions on that? There's your assignment. And that's it for today.